Here we'll look at two problems involving arcsine or arccos functions. So imagine you're driving down a hill, and I don't know if you've seen this symbol while driving. Sometimes you've got these, it's usually in orange, and you see this, this represents that there's you're going to go down a hill, and there's often a percentage written, okay, on that board, and it basically tells you how steep your the road is going to be. And essentially 13% means that if you go forward by 10 or it's not 10 but 100 meters, you're going to go down by 13 meters, hence the 10%, 10 over 13. So it's the ratio of the two legs of that triangle. And the angle we'd like to look to find is this angle here. Okay. So even though that's probably a much larger triangle, it's similar to the one I just drew, okay, because of the given information that the slope is a slope of 13%. So how do we find the angle? So if we look at the two quantities that are given to us, 10 and 100, that's the opposite side and the adjacent side, so that's related to the tangent. So we can tell that the tangent of theta is 13 over 100. So to find theta, we need the arctangent. Okay. When we're not there yet, we're going to look at the arctangent in the following video. So we're going to use the technology we know so far, so the arcsine and arccosine. So to have access to those, I need to know what the hypotenuse is here. So this is going to be using the Pythagorean theorem, the square root of 13 squared plus 100 squared. So that's the square root of 10,169. And now I can say that sine of theta, for example, is the opposite side over the hypotenuse. And that theta is just the arcsine of that value. Now this is clearly not a nice value, so you're going to have to use your calculator here. So if you set your calculator in degrees and use the arcsine function, you're going to get 7.4 degrees approximately. For our next problem, we've got an isosceles triangle. Okay, we know that the two sides that are identical are 7 and 7. We know this, the base is 10, and what we'd like to know is this angle, what it is, and this angle, what it is. So try to think about a solution, pause and come back. So one way to work with a right triangle is to split the isosceles triangle into two parts, thus creating two identical right triangles. So this one, so a right triangle with a hypotenuse of 7, a base of half of 10, 5, and we're looking for theta. So now 5 over 7 is adjacent over hypotenuse, so that's related to the cosine function. So the cos of theta is 5 over 7, so which means that theta is the cos inverse of 5 over 7. Using our calculator, this gives us approximately 44.4 degrees for theta. As for phi, well, we can use the fact that in a triangle the angles add up to 180 degrees, so this is pi minus 2 times theta, because theta is the same here on either side for an isosceles triangle, so this is pi minus 2 times the arccos of 5 over 7, and if you calculate this you get roughly 91.2 degrees for phi. It's almost a right triangle actually.